Hi, welcome to my video on proofs with angle bisector, median, altitude, and perpendicular bisector, part 1. Let's look at the definitions of each of these, just to review again. Definition of an angle bisector is a segment divides the angle into two equal parts. So if you take this angle A, B, C, and BP is in the middle, so if BP, which is a ray, bisects angle A, B, C, so I'm going to name them two angles, bisects, then angle 1 is equal to angle 2. It divides the angle ABC into two parts. So instead of naming the angles ABP and CBP, I do 1 and 2. Makes it easier to see. The definition of a median of a triangle, a segment drawn from a vertex of a triangle to the midpoint of the opposite side of the triangle. So a triangle has three vertices, therefore it'll have three medians. So if I let X be the midpoint of BC, then if I draw a segment from A to X, then AX is a median. A median leaves and goes to the midpoint of the opposite side. So X is the midpoint. Or we could have the midpoint of AC. So the midpoint of AC is Y. Then B leaves the vertex B and goes to the midpoint of AC. Then BY is the median. Or we could have the midpoint of AB, and the midpoint of AB could be W. That means that CW is a median. A median leaves the vertex and goes to the midpoint of the opposite side. So that's a midpoint, and that's a midpoint, and that's a midpoint. So three medians. An altitude of a triangle, a segment drawn from a vertex from the vertex of a triangle perpendicular to the opposite side of the triangle. So if we draw an altitude from P, then the altitude goes down perpendicular to QR. If we draw an altitude from Q, it leaves Q and goes perpendicular to PR. And we draw an altitude from R, it leaves R and goes perpendicular to PQ. So three vertices, three altitudes, same as three medians. And again, an altitude from P is perpendicular to QR. Altitude from Q is perpendicular to PR. And altitude from R is perpendicular to PQ. And the definition of the perpendicular bisector of a segment. A segment or a line or a ray bisects a segment at 90. So if FH is the perpendicular bisector of AB, that means that FH is perpendicular to AB and it bisects. And bisect means it cuts it into two equal parts. So the perpendicular bisector is AF is perpendicular to AB. Sorry, FH is perpendicular to AB and FH bisects AB. So it does both. We'll use these to do some proofs because they always come up when you're doing geometry and you're doing proofs or you're doing whatever. You'll find that these will always come back to work through on triangles, on quadrilaterals, on area, Pythagorean, everything. Okay, which diagram below represents the angle bisector, the median, the altitude, and the perpendicular bisector from A? So if you leave A, that's perpendicular, so that's an altitude. Altitude is perpendicular. If you leave A and draw this, then that bisects the angle, so that's an angle bisector. It separates the angle into two equal parts. And if you leave A and go perpendicular and makes the two of these equal, that means it's bisecting, so that's the perpendicular bisector. It does both perpendicular and bisect. And if it leaves here and goes to here, then that's let's put a line here, that's a median, because a median goes to the midpoint of the opposite side, making these two, so that's a midpoint, making these two segments equal, so it's a median. Okay, let's do a little proof. Prove the altitude drawn from the vertex or apex angle of an isosceles triangle is the median and the angle bisector. So we have a statement, so we have to prove this statement. An altitude is drawn from the vertex or apex angle of an isosceles triangle. So we have a triangle. Let's label the triangle as A, B, let's call it F and C. So we're given a triangle, ABC, in which AB is equal to AC, because the triangles are isosceles, so we have to have two sides equal. And that means that these are two sides equal. That means that angle A is the vertex angle, or the apex angle. The vertex angle or the apex angle is the angle formed by the two congruent sides in an isosceles triangle. So we have to prove that we're also given that AF is an altitude. An altitude, we're saying an altitude is drawn from the apex angle. So AF is this altitude. And we have to prove that the altitude is the median. So we have to prove that AF is a median and an angle bisector. So let's see what we can do. So we have two sides equal. So AB equals AC given. We also have that I'm going to say that we have AF is an altitude. I could put all the givens in one, but I'm just keeping them separate right now. That's another given. Okay. And as a result of the altitude, we have two angles over here at F. The two angles we have, because it's an altitude, that means that AF is perpendicular to BC. It's an altitude, that's the definition of an altitude. An altitude leaves the vertex and goes perpendicular to the opposite side. And as a result of being altitude, or being perpendicular, that means angle 1 and angle 2 are right angles. Definition of perpendicular segments or lines. Because if two segments are perpendicular, then they form right angles. And as a result, angle 1 is equal to angle 2 because of all right angles equal. I could have omitted this one right here and gone from 3 to 5, omitted 4 and called this 4. I could have said that if the adjacent angles of two perpendicular lines form linear pairs, then they're equal. But if we say that these two angles are right angles because of perpendicular lines and then say they're equal, then that's most times that's the way most students remember it. So we have AB equals AC. These two angles are equal. Now, if I say AF equals AF, then I'll have an ASS, and I can say it, but I can't prove the triangle's congruent. So what happens? I have to look at it another way. So that angle B is equal to angle C. So this angle B is equal to this angle B here is equal to this angle C, and that's because of the ITT. If two sides of a triangle are equal, then the angles opposite those sides are equal. So now we have 1 equals 2, B equals C, and AB equals AC. So we have a pair of triangles, AFB, congruent to triangle AFC, and it's AAS congruency. So because we have our triangles equal, that means we can have that FB is equal to FC, CP, CTC. Corresponding parts of congruent triangles are congruent. And because we have these two segments equal, that means F is the midpoint of BC. And that's definition of a midpoint. And because we have F as a midpoint, that means that AF is a median. Why? Because if that's a midpoint, then AF is drawn from the vertex to the midpoint, so that's the definition of a median. Now we have to prove that AF is an angle bisector. So we do that. If this is an angle bisector, that means, let's call these two angles 3 and 4. That means that angle 3 is going to equal angle 4 because these two triangles are congruent by ASS. So angle 3 is equal to angle 4, CPCTC. Corresponding parts of congruent triangles are congruent. Because the two angles are equal, that means that AF bisects angle BAC. Definition of an angle bisector, BIS. So that means that AF is bisects, so it's the angle bisector. So we proved it's a median right there. We proved it's an angle bisector there. So we've done the proof. Again, notice from the statement, I had to draw the diagram, fill in the givens, fill in what I had to prove, and then do the proof. So nice little proof. But again, I'm reviewing altitudes, medians, angle bisectors, etc. We have another proof that I want to go over now. Oh no, I didn't look at the page directly. Drawing an altitude from the vertex angle of an isosceles triangle is very useful in setting up two right triangles. 2A. So if you have two sides of a triangle equal, which means it's isosceles, so if you draw an altitude from the apex angle or vertex angle perpendicular to the opposite side, what you did, or what we're doing here, is we're setting up the C, A, and B. We're setting up the PY, TH. We're setting up the Pythagorean property. And the Pythagorean property is C squared equals A squared plus B squared. In other words, this is the hypotenuse, these are the legs. So it's the hypotenuse squared is equal to the sum of the squares of the two legs. And that's very useful in finding different sides of this triangle. And we also, if we drop a median between these two congruent sides, then we can also have that this down here is the base, and this will be the height. So because these two, let's say I give you, this is say 10 long, that means because it is perpendicular, that makes it not only an altitude, but it makes it a median. So that means these two sides are going to be equal right here, because that's a midpoint. And if you happen to have this, combine it here, make this hypotenuse 13, we can find the area of the triangle. So drawing the altitude allows you to do the area of a triangle, which is half the base times the height. So I could use Pythagorean to work out the height and then sub it in here to get the area. So again, dropping the altitude between the two equal sides splits the base and can help you find the area of the triangle because it can help you find the height. Or, again, if we look at it, if we got the two sides equal and we drop an altitude from the vertex angle and make it perpendicular, then we could have some right triangular trig. Because we have a right triangle, then we can use Sakatoa. And if you reviewed the introductory to trig, Sakatoa, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So you can use this to find with the trig, you can find the sides of the angles, you can find the ratios, you can work out a lot of parts of the triangle. And if you have a special right triangle, let's say you have not only these two sides equal, but you have this side equal. So you have an equilateral. Let's say you got an equilateral triangle. And in an equilateral triangle, you have all three sides equal. So that means you can drop an altitude from here to here, or an altitude from here to here, or an altitude from here to here. No matter how you draw your altitude, they're all going to be the same. So there's the altitude coming down between these two congruent sides. That means if this is an equilateral triangle, this angle is 60 and 60, and this angle here is 60, but because that's 90, 60, then this is going to be 30, 30. Why? Because these two sides are equal, and this is an altitude. This is an angle bisector, so this 60-degree angle is split into two equal parts. Or if this is a 90, and this is a 60, that's 150, so this angle is 30. And the same with this triangle. You have a 90, 60, 150, that makes it 30. So you have a 30, 60, 90 right triangle. And we also know that in trig, opposite 30 is n. Opposite the hypotenuse is 2n. And opposite the 60 is n root 3. That's a special right triangle with the length of the sides. So very important, when you have two equal sides, drawing the altitude can do a lot of these ideas. Okay, let's look at some proofs now. A segment drawn from the center of a circle perpendicular to a chord bisects the chord. Again, we have a circle, so we have to draw a circle. A segment drawn from the center of the circle. So let's name O as the center of the circle. And the segment is perpendicular to a chord. So let's draw AB. A chord is a segment connecting 2 points on the circle. So that's a chord. There's 2 points on the circle, A and B. So a segment joining those 2 points, that's a chord. Now we have to, it says a segment drawn from the center perpendicular to a chord. So it's perpendicular to the chord right here. So that means that we have to prove that it bisects the chord. So let's put down what we're given. We're given O is the center of the circle. Okay. We're also given that AB is a chord. And we're given that, I'm going to name this angle as F because it's perpendicular to the chord. I'm going to have it drawn so it intersects at F. So OF is perpendicular to AB. So I want to prove that FA equals FB. So prove it bisects the chord. So prove that OF bisects AB. So let's draw this statement here. Let's draw this down here. Let's do the statements and reasons. Here we go. How are we going to do it? Well, we have to set up, we have to draw OA and OB. When I connect OA and OB, I'm allowed to do that. I'm allowed to construct those two segments from that center. So what happens when you construct those two segments? These are the radii of a circle. So what we did when we constructed OA and OB, we made two triangles. So if I can prove that these two triangles are congruent, that means that these two segments are going to be equal, and therefore it bisects. So let's start. How will I prove the triangle is congruent? Let's put the givens down. O is the center of the circle. AB is a chord. And OF is perpendicular. So I put all the givens in one. Check with your teacher if you're allowed to do that. Because some teachers want you to do them separate. Now, I have to draw D-R-A-W, draw OA and OB. And that's what we call construction. We're allowed to draw a segment between any 2 points, so OA and OB are drawn. And as a result, we have that OA equals OB. And the reason, radii, plural for radius, radii of a circle are equal. Because in any circle, if I drew this segment right here, that would be equal to OB and OA. If I drew this segment up here to this point on, that would be equal to OA, OB, and so all four of them would be equal. Okay, what else do we have? We have perpendicular, so we have OF perpendicular, so that means that angle, and let's name these two angles, angle 1 and angle 2. So angle 1, instead of going OFA and OFB, I'm going to put 1 and 2 in. Angle 1 and 2 are right angles. Definition of perpendicular lines. Because the lines are perpendicular, the angles are right angles. That means that angle 1 is equal to angle 2. Because all right angles are equal. So I have this side equal to this side. I have these two angles equal. Now, what else do I have here? If I say OF equals OF, I can, but if I mark these OF equals OF with two strokes, I'll have an ASS, and I can't have that. So I have to get another way to get the triangles congruent. And I remember that angle A equals angle B. Angle A equals angle B because of ITT, isosceles triangle theorem. And as a result, I have 1 equals 2, and A equals B, and these sides are equal because they're radii, and I have triangle OFA is congruent to triangle OFB by AAS congruency. And as a result, we have that FA equals FB. And that's CPCTC. Corresponding parts of congruent triangles are congruent. and that means that OF bisects AB. Because FA equals FB, because FA equals FB, then it's a bisector. That's definition of segment bisector. So, from this statement, I drew the diagram, I set it all up, and I did this proof. Again, nice thing to learn how to do that. And one more proof before we finish. Prove if any point on the perpendicular bisector of a segment is equal distance from the endpoint of the segment. So what we have is any point on the perpendicular bisector of a segment. So we have a segment, and we'll name it HA. Let's say HQ. Call it HQ. And we'll draw this down here. It says any point on the perpendicular bisector. So what we'll do, we'll name this an A, and we'll name this B. So it says any point on the perpendicular bisector of a segment is equal distance from the segment. So what we're going to do, we are given that we have HO is, okay, sorry about that. We're going to say that AB is the perpendicular bisector of HO, and AB intersects HO at T. So let's name this T. So we have AB is the perpendicular bisector of HQ, and we want to show that any point. So we'll let P be a point on the perpendicular bisector AB. So we'll put a point on the perpendicular bisector right there and call it P. So there's any point on the perpendicular bisector. Equal distance. So equal distance means I have to join. This point is equal distance from the endpoints of the segment. So that means I have to prove that PH is equal to PQ. Any point on the perpendicular bisector. This is the perpendicular bisector. Any point on it is equal distance from the endpoints. So, how are we going to do the proof? Again, we have to do the columns, statements, and reasons. Here we go. So, we got AB is the perpendicular bisector of HQ at T. Now, how are we going? Let's see, we got a perpendicular bisector. So what is the perpendicular bisector? Well, the perpendicular bisector AB intersects AB at right angles, and it bisects. So let's go with AB is perpendicular to HQ. This is the given. And this is definition of perpendicular bisector. And if it's perpendicular, then again, let's name this angle 1 and 2. Same thing again, angle 1 and angle 2 are right angles. Definition of perpendicular segments or lines. Oh, 1, forgot to put these in to keep it in order so you can see what goes with what. Angle 1 equals angle 2 all right angles equal. And what else do we have here? Oh, we have that AB bisects HQ. That's a given. Nope, that's, yes, it's given because it's a perpendicular bisector. That means that if it bisects, that means that TH equals TQ. Definition of, if you bisect, you cut the segment in 2 equal parts. Segment bisector. And we have, let's see what we have. We have angle 1 equals angle 2. We have this segment, TH equals TQ. Now we need another angle. We need this angle, we need this angle, or we need a side. These are the two sides we're trying to prove equal. So we got to go, oh, I see it, that PT equals PT, common side. PT is a common side to both triangles. So notice now we have side, angle, side. So number 8, so triangle ATH is congruent to triangle ATQ. So the two triangles are congruent, side, angle, side. Side, angle, side. Congruency. And as a result of the triangles being congruent, PH equals PQ. CPCTC. So, brings us to the end of the proof. Brings us to the end of this video on showing you about angle bisector, median, altitudes, perpendicular bisector, etc., etc. And hope you enjoyed the video. Hope you learned something. And if you did, click the like button, the subscribe button, notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you very much. Bye-bye.